So I said to myself, why don't they call equivalent fractions equal fractions? Do my ragamuffins know the difference? And then I realized, well, equi means equal and valent talks about the value. So what they're really trying to say is that equivalent fractions talk about or represent the same value, but they're not the same fraction. They're made up of different size parts and they have different numbers of parts. And so today we're going to take a look at equivalent fractions. So let's start with what we understand. So 1/2 of a small rectangle could be equal to 1/4 of a larger one if the holes are not the same size. So if you take a look at these two rectangles here, the first one has, it's a 2x4 rectangle, and it shows the first half of it in red as shaded. And each of those fractional parts, unit fractions, represent 1/2 of the whole. So the next fraction is a fourth, 1/4, and we know that 1/2 is greater than 1/4. However, in this case, the amounts are exactly the same because the second fraction in orange is twice as large. So when you divide that fraction into 4 equal parts, one part out of 4, 1/4, is actually the same amount. It takes up the same area, or the same amount of space as the rectangle in red. So we've got 1/2 in red, the same amount as 1/4 in orange. And from that we can say that equivalent fractions take up the same space or have equal values with different numerators and denominators. For example, 2/4 is the same or equal to 3/6. Both fractions are equal to 1/2. If you eat 2/4 of a donut, or if you eat 3/6 of a donut, both times you've eaten 1/2 of the donut. Of course, the important thing is the whole has to be the same size. The donut has to be the same size. So this first problem that we're going to take a look at deals with equivalence on a number line. And you can see that the pictures that are given are of two number lines, both of them from 0 to 1 to show one whole. The first one we're going to have show us fourths, and the second one will talk about eighths. The problem wants us to decide whether 3/4 and 6/8 are equivalent. Do they talk about the same total part of the number line? So I've divided each of them in half so you can see that those match up, and then we're going to divide each of them in fourths so you can see that those match up. The second number line we're going to divide again into 8 equal parts, and then what we should do is label each of the number lines. So the first one we're going to start with 1/4. I don't label the middle as 2/4 even though it's the same as 1/2, and then the third fourth labeled as its name suggests, 3/4. On the second number line we're going to go ahead and show eighths, 1/8, 2/8, 3/8. Again, we're not going to show 4/8 because that's the same as a half, 5/8, 6/8, 7/8, and then one whole, which we could label as 8/8, but we're going to leave it alone. So I need to show where 3/4 is on the first one, and I'm just going to go ahead and put a red dot there and label that as 3/4. The second fraction, 6/8, we're going to identify where that is on the second number line. We'll use yellow, and then clearly it shows that 6/8 is the second to last increment on the second number line. So the question being asked is 3/4, are 3/4 and 6/8 equivalent fractions? So, and they want us to explain our reasoning. So 3/4 does equal to 6/8 because they both occur on their number lines at exactly the same place. And you can see because they have lined up the number lines with the zeros and the ones exactly on top, you can see that 3/4 is exactly above 6/8. So we know that they are the same. So the next problem we're going to do asks us to compare fractions that have the same denominator. The denominator, of course, tells us about the size of the pieces because it lets us know how many equal pieces it's going to take to fill the whole. So if the denominator is the same, we know that the pieces are the same size. We're supposed to compare 7/8 and 6/8. Well, if the first fraction has 7 pieces and the second one has 6 pieces, it's not too difficult to tell that 7/8 is exactly the same. That 7/8 is 1/8 more and definitely greater than 6/8. So they want us to say which of the two is greater and explain or show our reasoning. Well, since 7 is greater than 6 and both fractions are made up of the same size pieces, 7/8 is greater than 6/8. The next problem asks us to compare fractions with the same numerator. The numerator, of course, is the number on top of the fraction bar, and the numerator tells us how many pieces that we're actually dealing with. They don't talk about the size of the pieces. That's the denominator, the number that's down below. The numerator, being the same, tells us we have the same number of pieces in both fractions. So the question is, how does 4/3 compare to 4/6? So since I know that thirds are twice as big as 6, it's not very difficult to understand that 4 larger pieces are going to be greater than 4 smaller pieces. So 4/3 is greater than 4/6. The last question asks us to compare fractions with different situations. So the first thing I have to do is take a look at the fractions being compared and see what strategy I can use to help me figure out the answer. Well, the first one says 4/6 and 2/6. Those are the fractions being compared. And I can tell that the denominator is the same size, which means that they're the same size pieces. So 4/6 is greater than 2/6. The next question, if I look at the numerator and the denominator, I see that 8 is the numerator, 8 is the denominator, 4 is the numerator, 4 is the denominator. I can tell that the numerator and the denominator are exactly the same, which means I'm talking about one whole. So 8/8 is equal to 4/4 because they're both equal to one whole. The second part of this problem refers to a word problem or situation that they want us to figure out. Which strategy can we use? An ant, it says, crawled 2/6 of the length of a bench, and a spider crawled 3/4 of the length of the same bench, which means our whole is the same size. So I'm going to compare my numerators and my denominators. And the first thing I notice, of course, is that 3/6 and 3/4 have the same numerator. If they have the same numerator, that means we're dealing with the same number of pieces. Since they have the same number of pieces, I'm just going to take a look at the denominator to see which pieces are larger. And 6, being a larger number, means more pieces are going to have to fit on the same whole. So 3/6 compared to 3/4, since 6 are smaller, 3/6 is less than 3/4. Why? As I said, because 6 are smaller than 4ths, or 4ths are larger than 6, and since they have the same number of pieces, 3/6 is going to be less than 3/4. And for my explanation with the sign, I've already done that. So I hope this helps you understand how to compare fractions with the same numerator, with the same denominator, and if the numerator and denominator are the same number, meaning one whole. I hope now you can also understand that equal fractions and equivalent fractions are not exactly the same thing. An equivalent fraction talks about different numerators and denominators, however, the same size, the same value. Okay, hope that helps. Bye.